Good afternoon everyone. So today we are going to see the second lesson. And what is the name of that lesson? Only give the answer, don't shout, okay? So work and energy, these are the physical quantities. We know that there are two types of physical quantities. One is scalar, second is vector. Scalars are those physical quantities which are explained by magnitude alone. For example, when we bring the milk 5 liter, so 5 liter means it is a magnitude. When we purchase the sugar 1 kilogram, so 1 kilogram is the magnitude. Actually magnitude have two things, one is number and second is unit, okay? So these are called as scalar quantities. In the same way, this energy is the scalar quantity. We know that in the 8th class we define the energy, the capacity of the body to perform the work is called energy. Everyone are familiar with, without taking any kind of diet or without taking any kind of energy, we are unable to do the work, okay? So energy is the capacity of the body to do the work. So depending upon the energy there is a work. So actually work is nothing but it is the product of force and displacement. Now work is denoted by which letter? W. Force is denoted by F and displacement is denoted by S. Okay. Here as the force is a vector quantity. Listen, because force depend upon the direction attracted toward the downside. So force is the vector quantity and the displacement which is denoted by S, it is called a scalar quantity. So this is the definition as well as the formula. We can define like that. Everyone should be ready to give the answer. The product of magnitude of force and magnitude of displacement along the direction of force is called work. Listen once again, I am repeating the definition. Pay the attention. The product of magnitude of the force and the magnitude of displacement along the direction of force is called work. Is anybody ready to tell the definition? What is the definition of work?
If the product of force, magnitude of force and magnitude of direction is along the direction of force is called work.
You forgot one thing. Product of magnitude of force and magnitude of displacement, it is not direction. Later on we are saying that in the direction of the force, it is called a work. Okay, sit down. Now we know that there are two units. One is SI unit, that is the standard international, and second is CGS unit. So the unit of work in SI, it is 1 joule, and the unit of the force is 1 Newton, and unit of the displacement is 1 meter. Now we can define the 1 joule. So see everyone, pay the concentration here. Starting from here, backbenchers, look here. If the force of 1 Newton displaces an object through 1 meter in the direction of the force, then the amount of work done is called 1 joule. म्हणजे तुम्ही स्टार्टला द युनिट ऑफ द वर्क इज 1 जूल न म्हणता इकडनं जर स्टार्ट केलं तर फार चांगलं राहील. डबल पहा एकदा. Force of 1 Newton displaces an object through 1 meter in the direction of the force, then the amount of work done is 1 joule. सांगो कुबडे.
If a force 1 Newton displaces an object through 1 meter in the direction of a force, the amount of work done on an object is called 1 joule.
And this is a repeated part, it is not new part. Okay, sit down. Now second unit. We know that there is a CGS unit. Now CGS unit is 1 erg. Okay. Now CGS unit of the force is 1 dyne. And CGS unit of the displacement is 1 centimeter. Okay. Similarly, we can define the 1 erg. Look here. The force of 1 dyne displaces an object through 1 centimeter again in the same direction, then the amount of work is said to be 1 hour. I am repeating both the definition, you make the comparison there. Look here, it is the original formula of the work. So depending upon it, work has the SI unit joule, CGS unit is hour, but when we define the work, we should know what are the individual units of force and the displacement. Okay, so force has the unit Newton, displacement has meter. In the same way, in CGS, the unit of the work is erg, the unit of the force is 1 dyne, and the unit of displacement is centimeter. So directly we can define when the force of 1 dyne causes the displacement of 1 centimeter in the direction of force, then the amount of work is called 1 erg. Now there is a one relation, the relation between the joule and the erg. We know relation 1 meter is equal to 100 centimeter and 1 Newton is equal to 10 raised to the power 5 dyne. 1 meter equal to 100 centimeter. So using this formula, now simply I am writing the symbols. So 1 joule equal to 1 Newton into 1 meter. Now what is the value of 1 Newton? 10 raised to the power 5 dyne. And what is 1 meter? That is 100 centimeter. Now according to your mathematics, when the bases are equal, then we add the indices. So 5 plus 2, 7. So 10 raised to the power 7 and remaining part is dyne into centimeter. So 10 raised to the power 7. Now dyne centimeter is nothing but it is a erg. So therefore we can write 10 raised to the power 7 erg. So this is the final relation between the units of the joule and the erg. Do you understand? And this is the very important part as far as our examination is concerned. So everyone be ready for it. Okay.